Hello and welcome to EBRD's COVID-19 Resilience Framework, Environmental and Social Assessment Training Programme. This is Video 8, GIS and Spatial Data Management. My name is Stuart Hume from a company called Environmental and Social Advisory Services, or ESAS. And for the purpose of this video, I'm joined by my colleague, Colleen Abel. Colleen, could you please introduce yourself?
My name is Colleen Abel and I'm a GIS specialist. I've been working for over 18 years now in the field of GIS, remote sensing and geospatial technology, primarily for global offshore and onshore oil, gas, mining and development projects, with focus on environmental and social applications.
So Colleen, when you're ready, please take us through your introduction.
Well, welcome to this webinar where, as described, the purpose is to illustrate how the use of GIS technology and spatial data management can help to support environmental and social due diligence studies, providing the consultant with a broad understanding of how and where a project could interact with environmental and social receptors. Using GIS and spatial data has many key benefits, including the ability to collate and assess key datasets identified during Task 1, to identify the type and proximity of key environmental and social receptors in relation to the project footprint, to assist the planning of Task 2 site visits, particularly targeting areas of key focus, especially where only specific locations may be visited due to either time or other project constraints. To incorporate data that has been gathered in the field using GPS technology, mobile mapping applications, and GPS tagged digital photos. And finally, presenting findings using GIS analysis and illustrated maps for reporting purposes.
Thanks, Colleen. Now, you and I have worked together on a variety of projects in different parts of the world. And one of the things that I've always benefited is the preparation of a map book, which identifies the key environmental and social receptors that I'll be visiting and exploring during the site visits. And that's really the main way that I've benefited at an early stage of the project from the use of GIS. Please now take us through the overview of the application of GIS to various projects.
So GIS is a system for capturing, storing, analysing and managing spatial data and associated attribute information. Effectively, this provides a database of geospatial information layers which can be visualised as a digital and interactive map. The real power behind GIS lies in the breadth and the quality of data that's collected within the database, and the software analysis and presentation tools available within the software. As illustrated here, the different elements of a GIS map are spatially referenced to each other, and this may include layers such as base maps, imagery, elevation, land cover, population, and parcels or zones that represent different surface features. GIS stores and displays a variety of geographic information, including raster data, where each cell or pixel stores an attribute value, and examples of this can include satellite or aerial imagery, digital elevation models, or scanned topographic maps, for example. Also vector data, which takes the form of attributed points, lines, or polygons, which represent surface features. And examples of these could include community locations as point features, rivers, roads, railways, or utilities as polyline features, and, for example, habitat mapping or protected areas represented as polygons. You can also incorporate non-spatial data, and this includes tabular information on sites of interest, which can be linked to the geographic data, or also the example of field photographs, which can be positioned according to the location or direction of capture. The use of geospatial technology and spatial data management can provide better understanding and communication of key project information. By managing and maintaining project information in a robust manner, this ensures that the information captured forms the basis for ongoing project work, subsequent assessment, and continues to support reporting as the project progresses. GIS is a tool for the systematic compilation and assessment of geographic information and spatial data sets as its basic function. It provides the ability to collate and build databases which can manage huge volumes of spatial data and often multiple spatial data sets, which may often have a multi-temporal or seasonal value attributed to them. It supports further analysis of the data, which is driven by the study or the application needs, assessing key information and data which is relevant to project locations, to visualize the key sensitivities and risks and help improve decision making and project planning. This is particularly important for providing focus to the site visits in Task 2 and field surveys and improving field data capture through the use of available technology. It also provides the ability to visualize data and findings in a way that can then be clearly communicated to users and also project stakeholders. And it maintains the spatial data in an archive in support to project development or future project assessments.
Thank you, Colleen. And so let's now move on to Task 1, the review of existing information during the environmental and social assessment process.
Task 1 requires a review of existing documentation and data in support to the ESDD study. The GIS specialist should closely liaise with the environmental and social specialists during each of the steps which are described in the following sections. The key task here is to undertake a desktop review of available sources of supporting documents and spatial information. During Task 1, the consultant should request access to and review of the client's GIS, and then add additional information that is available in the public domain. This can be a very cost-effective way of gathering information about a project and its context, and it will become the basis for identification of features of interest for focus within Task 2. To identify the data available, it is necessary to define an initial study area to give focus to the desktop review. The study area can begin to be defined by taking into consideration some of the following information. A key data layer will be the project's footprint and the area of influence related to that project, which may be defined within the environmental and social impact assessment. Associated facilities or infrastructure can also be brought in, as well as hydrological data and administrative boundaries of the regions or districts in which the project facilities and infrastructure are located. As well as this, any known sources of cumulative impacts can be brought in to influence the identification of the study area. It's likely the study area will continue to evolve as further information is gathered during the course of the Task 1 assessment. Once the study area is defined, publicly available data sources should be checked for relevant information that may not have already been captured within the client's GIS. These may be sourced from internet research, maybe from public available information, spatial data and maps, or publicly available documentation such as ESIA. In addition to the core GIS datasets that may be sourced during the desktop review, it's also often a requirement to obtain aerial or satellite-derived imagery in order for additional image analysis to be undertaken prior to the field survey. Checking for freely available sources of satellite or aerial imagery, such as Google Earth or Sentinel satellite missions, can provide a very useful base map, which can be used for analysis and can also be used in the map book used in Task 2. The desktop assessment includes a review and analysis of global and also nationally available databases, such as the Integrated Biodiversity Assessment Tool, or IBAT, or, for example, Global Key Biodiversity Areas, KBAs. Datasets can also be obtained from national sources, for example, administrative boundaries, infrastructure, maybe population or cultural heritage data, specialist local species studies, or other baseline assessments. Wherever possible, it's really important to capture all of this information that has a geographical context related to the project, and capture that and maintain it within a GIS database or geodatabase to allow for analysis and delivery of the created products in a GIS-ready format. As a minimum requirement to compiling a GIS project, it's anticipated that the following datasets would most commonly be used. Project data will include any data that has been provided by the client, including the project footprint and associated infrastructure. The initial study area derived should also be included. As we've mentioned, the use of imagery to create a base map is really important so that other types of GIS data can be placed on top as reference layers. And typical sources include Google Earth or imagery base maps that may be available through GIS software providers such as Esri, freely available satellite imagery such as Sentinel-2 or digital elevation models, or other commercially available imagery that may be made available from the client or can also be purchased. Settlements and public infrastructure can also be added using sources such as OpenStreetMap, which contains a variety of GIS-ready spatial datasets. And this includes natural features such as land cover, landform and soils, and also natural hazards datasets. The presence of protected and important areas for habitats and species can be added with boundary information obtained from the World Database of Protected Areas, amongst various other sources. And examples of protected and sensitive areas include UNESCO World Heritage Sites, Ramsar wetlands of international importance, Natura 2000 sites, national parks, or key biodiversity areas, which include important bird areas and Alliance for Zero Extinction sites.
Thank you, Colleen. And so, just quickly, in relation to the data associated with the protected and sensitive areas, this data is freely available already in GIS format. Is that correct?
So there are various sources of protected and sensitive areas data sets. The ones that we've mentioned, IBAT and the World Database of Protected Areas, some have restrictions around commercial use and others are open source and publicly available data. So that would be a step for the GIS specialist to review the available data sources and identify which are suitable for use.
Great, thank you for that. Please carry on.
So each source of spatial data, as we've just mentioned, should be evaluated for their relevancy and accuracy, and also their suitability for use in the project. Once they're confirmed as suitable for use, the GIS data shall be stored in a suitable format, such as a shapefile or a geodatabase. There are many different options for analysis of data, from very simple calculations of feature size, such as the size of a project's direct footprint or the estimated impact area, to analysis of feature proximity. For example, you may want to consider the distance of the project from communities or from local water supply. This can lead to more in-depth analysis, such as longer-term site monitoring, and that may employ satellite imagery acquired at different times, or the classification of vegetation for identifying habitat mapping and change detection. A series of GIS maps should then be prepared to illustrate the project's key findings. And these could include maps representing the physical footprint of the project and any temporary areas of land that are to be used, the location of any associated facilities and sources that have been identified of cumulative impacts, existing infrastructure within the study area, for example, roads, pipelines, telecommunication lines, and also features such as public buildings, schools, and healthcare facilities, for example. And then the key environmental and social receptors that have been identified in liaison with the environmental and social specialists must be included. And they may illustrate things such as the location of nearby communities, biodiversity features that have been identified, important water bodies or sources of water, or also cultural heritage resources and cultural heritage sites. Over the next few slides and images, we will be looking at a simple working example, a case study which is based upon the concept of a wind power development. In this example, we've been provided with data from the client relevant to the project, which includes point locations for the wind turbines that have been proposed, associated access roads, infrastructure, and facilities that are planned for development. Base maps, including elevation data and satellite imagery, have also been included with the client data. To define the initial study area that will be used for the collation of the data in Task 1, the project's direct footprint and broader area of influence have been mapped and included with the client data based on previous ESIA. Hydrological datasets, including watercourses, water bodies and catchments, have been sourced to look at the location of the project in context to the hydrological network. And further datasets, including populated places, population data, existing infrastructure and administrative boundaries, have also been incorporated so as to identify the social context of the project area. All of these inputs are combined and used to delineate an initial study area which can focus further data collection. The study area may evolve as further data is sourced and becomes available through additional stakeholder engagement and/or the field reconnaissance during Task 2.
Thanks, Colleen. And so just to be clear, the study area is defined by the red outline, is that right?
Yes, there may also be additional species range data or protected area extents that are identified and can be brought in to influence the extent of the study area. Other information that may become available during the assessment with regards to wider indirect or cumulative impacts can also be incorporated. Once a study area is defined, it's important to undertake the desktop review and to compile, assess and store the GIS data that has been sourced. It's also important to document this process and record any gaps of information for further recommendations to the specialists. As well as rivers and water bodies, further hydrological data may be sourced, which may include things such as flood zones or wetlands. Added to this, land cover can be sourced from either regional or national datasets, and this can provide an initial overview of the types of vegetation and the habitats which may be present within or around the project area. The land cover data can also be compared with available satellite imagery to help review its accuracy and can be assessed further during Task 2 and the site visits in order to ground truth certain habitat assumptions that have been made upon the data. Broader population data, census information and infrastructure such as roads, railway networks and utilities can also be brought in to supplement the project. This data is often freely available via sources such as OpenStreetMap or also via national agencies and their online databases. Information on cultural heritage sites, here represented by the blue point locations, may be available via existing documentation such as the ESIA or other social baseline documentation. In support to the assessment of the potential for any impacts to biodiversity, spatial data can be used to identify the proximity of the project area of influence to protected or sensitive areas within the study area. And in this example, you can see the protected area polygons are highlighted, and you can see that 2 of the proposed wind farm sites are within the protected area boundary, and others are in close proximity. Also, one of the protected areas is potentially crossed by an access road. So all of these are features that would be of interest for the Task 2 site visits and also for discussion with stakeholders. Once all the available data has been reviewed and compiled within a GIS database, then some initial analysis can be applied in order to support the review and to identify where the really key areas for focus in Task 2 are located. A GIS project is created to help visualize and assess all of the spatial data, and a series of overlapping layers of spatial information and analysis tools which are available within GIS will help us to obtain an overview of what the key environmental and social issues and also the potential areas of impact related to the project are within the study area. So in the example on the screen now, the project's direct footprint has been assessed and suitable buffers have been applied to the roads, the access roads, the proposed wind turbine locations and the facilities to understand the areas within which impact may occur due to project activities. The overlap of this footprint can be compared to features of interest and further highlighted in the mapping to help the specialists in Task 2. In this example, the areas highlighted in orange indicate where the potential environmental, biodiversity or social receptors are located within the project buffer areas. The output of this desktop assessment should be visually presented with the initial results of the review illustrating certain outcomes and quantitative information via both hard copy and digital mapping that the specialists can use in the field.
Great, thank you, Colleen. And so now let's move on to task 2, site visit and discussions.
Thanks, Stuart. Well, the spatial data collated as part of the desktop-based review and also the assumptions that have been made upon it during the assessment need to be verified during task 2, including the stakeholder consultation and the field visits. So GIS should really be a key component of the site visits, as there may be locations or data sets that need to be verified in the field, and that may be protected area boundaries, types of vegetation, or areas of forest loss, for example. The use of the mapping that's being completed in Task 1 should be available to the specialist in both digital and hard copy form, presented as a map book or a series of field maps that can be used to help navigate the specialist to locations and also enable them to record field data in a GIS-enabled manner. The use of geospatial technology allows for the specialist to capture supporting geolocated field information and also, really important, field photography that can help those involved to further visualise the situation in the field in more detail. Field-based surveys should aim to deploy as much technology as possible in support to the collection of the field-based data, and this may be via the use of handheld GPS units, GPS-enabled cameras for geotagged field photograph collection, the use of mobile devices and mobile mapping applications. All of this technology can be deployed to support field-based surveys. Digital photographs and other information collected in the field can often be passed to the GIS specialist without sufficient information about the location the field photograph has been taken or the viewing direction, for example. This makes it almost impossible for the GIS specialist to incorporate them accurately into the GIS. Using GPS-enabled technology, such as GPS-enabled digital cameras, will ensure that all field data is captured along with information on its precise location and maximises the value of that information which is being taken in the field. In addition, numerous mobile mapping applications exist which can be used in the field. These can be used to locate yourself and also the boundary of nearby project features that may not be physically marked upon the ground, to navigate to locations of interest in the field, which are marked on the digital and the hard copy mapping, to view and record also the compass direction on interactive maps on mobile applications, also to track your routes that you have taken in the field, and this may be either driven routes or walked routes through the site. You can assemble field notes against a reference position on the map and record the location of key activities such as stakeholder engagement. This technology also allows you to take field photographs that are geotagged and use basic map functionality such as tools to measure distances or areas. And all of this can be exported for all of the collected field data into a GIS-ready format for further use by the GIS specialist.
Thanks, Colleen. And one of the things I've always found is very important is to ensure that all the photographs taken during the site visit are geotagged so that we are able to understand and record exactly where they were taken. Please carry on.
In our case study example, which is now presented again on the screen, the consultant has prepared all of the desktop spatial data and the key data sets for the site visit purposes, including identifying the priority areas for the field visits. A suitable scale of mapping is selected, providing coverage of the project area at a resolution with a clear enough detail for use in the field. The consultant shall then prepare these field maps for use in hard copy or digital form the field maps here represented by the rectangular areas on the map. Each of these maps shall then be uploaded in advance of the site visit to mobile mapping devices to be used by the specialists. By deploying geospatial technology in the field, recording the sites that have been visited, taking the photographs, and collecting associated information, a real wealth of additional data can be collected and incorporated into the GIS project. The consultant should identify the appropriate and available geospatial technology required for use in the field, confirming the use is permissible against local legislation or regulations. A GPS-enabled camera can record high-resolution field images and be associated with notes that are recorded in the field using other handheld GPS devices used for navigation, for example. Mobile mapping applications on phones or tablets allow for the review of the digital maps and the use of the data that's been collected in Task 1 for navigation based on locations of interest which have been identified. Mobile devices also allow for recording of tracks that have been taken in the field and allow for GPS tagged records to be made at sites of interest with accompanying photographs taken with that mobile device. If permissible and available, lightweight drones can also be used to capture further imagery in the field, which can be added to the collection of imagery base maps incorporated in the GIS project. Drones allow for really rapid assessment over broader areas than may be possible to cover on foot, or the areas that may be inaccessible due to terrain or dense vegetation cover. All of the data which is collected in the field should be GIS enabled and easily extracted into the project's GIS on return from site. And this allows visualization of all of the areas which have been visited, the surveys which have been undertaken, and the locations of those really key field photographs.
Great, thank you, Colleen. So as we now start to close, let's have a brief look at Task 3, the analysis and reporting using the EBRD format. So essentially, GIS maps need to be prepared to support the key environmental and social assessment findings, and that will require close liaison with the relevant specialists that have been involved in the study. The projects that are included in the environmental and social assessment report should include details of the project's physical footprint, details of associated facilities, and also sources of cumulative impacts as well that have all been taken into consideration during the actual assessment itself. And also environmental or social receptors, including protected areas. And this includes social data, such as communities and public infrastructure that may be both used and impacted by the project. And part of the benefit of using GIS is to include an analysis of imagery. So you may wish, for example, to include a variety of land cover classifications, present the outcome of habitat mapping, and also details of the calculated area of a feature which is directly impacted by a project, such as a proportion of an agricultural field or certain type of habitat classification. Now, GIS solutions also support project reporting, and this is through the provision of quantitative statistics, static maps, and also through the development of interactive web maps and web applications to present the key findings of the environmental and social assessment in a more dynamic way. And so finally, Colleen, please talk us through the key issues associated with the analysis and reporting of metadata.
Metadata should be included, and key items that should be noted in relation to each data set include things such as the source of the data. So that's considering who was the data distributor, the original data creator or data owner, and if there is a URL link to that data source. Also, the validity of the data, so thinking about when that data was actually created. The information provided may be out of date or since have been superseded. It's also important to think about the scale of use of the data or the resolution of the data.
Great, thank you, Colleen. And so please finally provide us with a brief summary of the use of GIS.
Well, I think we've seen that GIS can play a really pivotal role within an ESDD study, and it can really help to inform each stage of the assessment. So just to run through and summarise again the key steps for a GIS component in any study, and these really are to, first of all, identify the GIS software which might be available, and also the technical resources that are required in support to that. To then liaise closely with both the client for access to their GIS data holdings and also the project's environmental and social specialists to really understand and define the study requirements. The next step then is to identify the project footprint and all of the data sets that are available in support to defining an initial study area. Once this initial study area has been defined, the GIS specialist can then undertake a broader desktop review of the many available sources for spatial data that we've seen, including those in the public domain. The GIS specialist should then compile the data, review and verify the data quality, and undertake any additional data analysis where that's required. They need to continue to work closely with the specialists and support them in planning the site visit and also preparing all of the field maps in this map book format, both in hard copy and digital outputs. And as we've discussed, the deployment of technology for those field visits is important for the field data collection, especially for the collection of these GPS photos and use of mobile mapping applications with all of the pre-prepared field map books loaded. Then all of the results are presented and illustrated in a clear map format in support to final reporting. And finally, as we've seen, data standards for robust data management are required, and those include the completion of metadata with the final deliverables. So I hope this webinar has provided you with a foundation of knowledge to take the use of GIS and geospatial data and technology further within your own applications, and also to be able to build it into your ESDD processes in the future. Thank you.
That's great. Thank you very much, Colleen. Well, this brings video 8, the application of GIS, to a close. Please refer to the additional information and resources that are available on the website. Thank you very much.